Hello, Wayland Middle School. Mr. Farley here to give you a couple more examples of the Pythagorean theorem. This time we're going to step it up a little bit and have side lengths that are radicals, okay? So a radical is when you have a square root, all right, with these. So let's just do this. We already know that the Pythagorean theorem can be written as a squared plus b squared equals c squared. And we know that the side opposite the right angle, known as a hypotenuse, we know that that will always be our c. Okay, so when I plug these in, and please remember, it doesn't matter which one is A and which one is B. These can be alternated back and forth. It doesn't matter. Just pick one. One of the legs is A, the other leg is B. So when I do this, I get A. So if I square A, it's really the square root of 10 squared plus, and here I have the square root of 8 squared is going to equal c squared. Just like we did before with whole numbers, we do the same thing here with these radicals or with these square roots. Guys, if you square a square root, you just undo that operation. So squaring a square root leaves you with the number inside the square root. That's all it is. So if you square the square root of 10, you get 10. If you square the square root of 8, you get 8. And that is equal to c squared. Putting these together, I get 18 is equal to c squared. And you know we are not trying to find the value of c squared. We're trying to find the value of c. So to undo a square, c is being squared. To undo that, we take the square root of both sides, and there you have it. A nice answer is the square root of 18. This here, you can write it in this form. There is a way to simplify this square root a little bit further. We're not going to talk about that right now, but just know that it is possible. And the third thing you can do is you can go to your calculator and just do the square root of 18 and get a decimal approximation for this value. But Mr. Robinette and I are happy with leaving it as the square root of 18. So that's the first example. Let's move on to the second example. Second example, same idea. All right, little more complicated this time because the hypotenuse is given to us, and the hypotenuse, as you know, is the longest side. That is your c. So when I fill in a squared plus b squared is equal to c squared, the Pythagorean theorem right here, I'm going to plug these in. Again, I will call this one my a and this side my b. So it's 6 squared plus b, which is y, so I'll call it y squared, is equal to the square root of 85 squared. Let's clean it up. 6 squared is 36. That's going to turn into a y squared. And if we square a square root, you just get the number inside, which is 85. Guys, solve this equation. That's all we need to do. If we solve it, we find out that y squared is equal to, I'm doing this right now in my head, if I take 30 away, that's 55, 49. Okay, square rooting both sides. And if I do that, the square root of y squared is y. The square root of 49 is 7. I just found out that the length of this side here, which is y, is 7 units long. So there you have it. All right, that's a second example, again with another square root. And we're hoping, Mr. Robinette and I are hoping, that you're not freaking out about the square roots. Take it one step at a time, and you can see it. So we thought we should show one more just to make sure you guys know and can follow. This one is, again, a little more complicated, this time for two reasons. But let's talk about it. We know Pythagorean theorem, a squared plus b squared is equal to c squared. Just like all the others, pick one side to be a, one side to be b, and we always know that the hypotenuse, the longest side, the one opposite the right angle, is your C. So let's plug it in. A, which is 10, and I'm going to square that, plus B, which is X, and I'm going to square that, is equal to C, which is 10 times the square root of 2, and then that's squared. All right, let's clean it up. Here we go, 10 squared. 10 squared to 10 to the second power is 100. I'm adding an x squared to that. And here is the first time you are going to run into a little problem. I want us to take this expression over here, put it in a little cloud for a minute, and let's think about it. 10 times the square root of 2 squared. That's what it says I'm doing. This square goes to both of these numbers. We know 10 squared is 100. We also know the square root of 2 squared is 2. And this is the operation involved here is multiplication. So 100 times 2 is 200. That's the math that's going on right there. That is 200. Now solve it. Look what happens. Subtracting 100 from both sides, I get x squared is equal to 100. I solve for x by taking the square root of both sides. The square root of x squared is x, and the square root of 100 is 10. So that means the length of the x side right here, or our b, will be 10 units long. So guys, this is a way to expand your knowledge of Pythagorean theorem. Now we are involving some square roots as lengths of sides, which is a little more detailed, but you can handle it. Take one little step at a time. As always, if you have any questions, concerns, or problems, please reach out to Mr. Robinette or I, and we'll get back to you as soon as possible. Hope you enjoyed the video. Take care.